Welcome to The Explainer. Today, we're diving into a massive shift in how we interact with technology. We are moving away from those simple, reactive chat interfaces we're all used to, and we're heading straight toward autonomous, action-taking systems. This is the era of AI agents. In this session, we're going to map out exactly how these agents are evolving. We'll look at the grand enterprise vision, and then we'll get right into the nitty-gritty code architecture that actually makes them work out there in the real world. So let's set the stage here. What exactly makes an AI agent more than just your run-of-the-mill chatbot? I mean, we've all used chatbots to help write an email or quickly summarize a document. But what gives an AI the ability to actually perform real work, to take action on your behalf, and reliably run in the background without you having to handhold it every single step of the way? Well, here is our roadmap for today to figure that out. First, we'll meet the enterprise AI agent. 2, we'll break down the anatomy of an agent. 3, we'll look at equipping agents with tools. 4, building durable agents. And finally, 5, orchestrating multi-agent systems. All right, let's kick things off with part 1, meet the enterprise AI agent. We're going to start right at the macro level. Just look at the sheer scale of something like Salesforce Agentforce. These AI agents aren't locked away in some IT sandbox like a neat little science experiment. No, they are embedded absolutely everywhere across the enterprise. We're talking about agents actively boosting sales pipelines, personalizing massive marketing campaigns, managing field service operations, and even tracking a company's net zero sustainability goals. They're integrated directly into the places where work actually happens day to day, like right inside Slack. And this really hits the nail on the head regarding the core philosophy of modern AI. It's not about replacing humans with a machine. It's about teaming up. The vision here is that humans and agents work alongside each other to drive customer success together. The agent takes on the autonomous execution and the heavy lifting, while the human steps back to provide the high-level strategy and oversight. Moving on to part 2, anatomy of an agent. So how do we actually build these systems to achieve that level of enterprise trust? Let's pop the hood and dissect what's really going on in these systems using the Dapr agents framework as our guide. At its core, an agent is just a highly intelligent building block. Yes, it uses a large language model, an LLM, for its reasoning and decision-making, but a model all by itself, that's not an agent. To become a true agent, that reasoning engine has to be combined with memory, external tools, and collaboration features, so it can actually execute tasks and solve problems autonomously to reach a specific goal. Now, to be truly useful, an agent absolutely has to have memory. Otherwise, it has the attention span of a goldfish, and every single interaction is starting from zero. The great thing about Dapr's memory options is that they can be swapped out effortlessly without rewriting the agent's core logic. You can start with quick, norm-persistent in-memory lists when you're just testing in development, move up to vector databases for things like semantic search, and then go all the way up to highly robust Dapr state stores. Those state stores give you rock-solid production-grade memory by hooking into nearly 30 different back-end providers. Beyond just having a memory, these agents need incredibly tight control over their inputs and outputs. They use unified API clients, which means you can seamlessly swap between different models, like OpenAI, Mistral, or Hugging Face, without a headache. They utilize flexible Jinja prompt templates to handle dynamic context. And critically, they rely on strict, structured JSON outputs. That's a big one, because it ensures the agent's responses aren't just clever, but they are completely predictable for whatever downstream system needs to process them next. Okay, part 3, equipping agents with tools. As smart as an LLM is at reasoning, it can't natively update your database or shoot off an email on its own. It needs tools for that. There is a very specific 5-step process here that's super important to understand, because the LLM doesn't actually run any code itself. First, a user submits a query along with a list of available tools. Second, the LLM analyzes that request and decides, okay, which tool do I need? Third, it outputs a structured JSON payload detailing the tool's ID and the arguments to use. Now here's the magic in step 4. The agent software parses that JSON and physically executes the external tool. Finally, in step 5, the results are fed back to the LLM, which then neatly summarizes everything into a final response for the user. Now, when a complex task requires using multiple tools, agents have a couple of gears they can shift into. They can fire those tools off all at once in parallel. That's incredibly fast and perfect for tasks that are totally independent of each other. But if one step absolutely depends on the result of a previous one, like say you need to create a user profile in a system before you can send that specific user a welcome email, the agent can carefully run those tools sequentially, one by one. And thanks to the Model Context Protocol, or MCP, this whole tool ecosystem is becoming completely dynamic. This is a real game changer. Instead of a developer having to hard code every single tool into the agent ahead of time, MCP lets agents connect to a server, discover what external tools are available, whether those are local Python scripts or remote cloud services, and start invoking them on the fly. It vastly expands what an agent is capable of doing in real time. That brings us to part 4, building durable agents. So we've got smart agents wielding these powerful tools, but what happens if the server completely crashes while our agent is halfway through a critical 3-hour task? Well, a standard agent is ephemeral. If the system goes down, it forgets everything, and you're forced to start completely over from scratch. It's synchronous, but a durable agent? That is designed for the real world. It runs asynchronously in the background, its state is persistently backed up, and it's built from the ground up to survive system failures. By backing the agent with Dapr workflows, developers are basically giving these agents superpowers. You get persistent workflow state management. If a tool unexpectedly fails, you get automatic retries and recovery mechanisms. And because of deterministic execution with checkpointing, an agent can literally pause, recover from a totally unexpected crash, and pick up exactly where it left off. It won't lose any data, and it won't repeat work it already finished. It ensures your agent finishes its job no matter what happens to the underlying infrastructure. Now, to pull off that kind of durability, the system uses event sourcing, meaning it literally replays the workflow code to rebuild its state after a pause or a crash. You might be thinking, wouldn't that create a massive, confusing mess of duplicate logs? Well, to keep things clean, Dapr uses replay-aware logging. This brilliantly and automatically suppresses duplicate log records during the recovery process. That way, developers don't get completely spammed with alerts while the agent silently rebuilds its local state in the background. And finally, part 5. Orchestrating multi-agent systems. One agent is great, for sure, but a whole team of agents? That is revolutionary. Welcome to the orchestra. Just like a world-class orchestra requires specialized musicians rather than one poor person trying to play every single instrument at once, a multi-agent system breaks down massive, complex tasks. It distributes the work among specialized, collaborating agents instead of trying to cram everything into one giant, monolithic AI. This drastically improves how your system scales, and frankly, it makes the underlying code much easier to maintain over time. You can actually conduct this multi-agent orchestra in 2 totally different ways. First, you've got deterministic workflows. Think of this like strict sheet music, where the developer defines the exact sequence of steps from start to finish. It's highly structured and highly predictable. Or you can use event-driven orchestration. This is a lot more like jazz. It's incredibly dynamic, relying on messaging, where agents act and react flexibly to events as they happen in real time. Using pub/sub, that is publish-subscribe messaging, for these event-driven systems is an absolutely brilliant architectural choice. Why? Because it completely decouples the agents. An agent can just publish a message to a central topic, and it doesn't even need to know who is listening on the other end. Other agents subscribe to the specific topics relevant to their specialized roles, which allows them to communicate in real time, act asynchronously, and scale up effortlessly without disrupting the rest of the workflow. So the crucial point here is that in these dynamic, jazz-like systems, you still need a conductor to prevent chaos. A central orchestrator manages this messaging flow. It can route tasks using simple methods, like a random assignment or a round-robin approach. But even more powerfully, it can use an intelligent LLM-based selection process. That means an overarching intelligence actually looks at the current context and dynamically decides exactly which specialized agent is best equipped to step up and act next. We've covered a lot of ground today, journeying all the way from the grand vision of enterprise AI adoption down to the exact code that ensures these systems are durable, communicative, and highly specialized. I want to leave you with this thought to take away. As these highly capable, durable, tool-wielding AI agent teams become the new standard in the software we use every day, how will we evolve to collaborate alongside them? The architecture is officially ready. The next step is how we choose to put it to work.